Welcome to another new video of interesting math problem on our channel Math Solutions for You. Please do like, share, comment, and don't forget to subscribe to our channel. The sum of squares of first n positive even integers is x, and sum of squares of first n odd positive integers is y. If x minus y equal to 1275, what is the value of n? We start this problem by first of all reminding ourselves a very basic question. So what are the first n positive even integers? So even integers are integers like 2, 4, 8, and so on. And the question is, do we need to consider 0? Because 0 is considered even, right? But is it a positive integer? And the short answer is no. So 0 is not a positive integer. So 0 is regarded as neither positive nor negative. In fact, the definition of a positive integer is any integer that's greater than 0. And in this case, we have the first n positive even integers. So these will be starting with 2 and then 4, 6, 8, and so on. So we can write x as the sum of 2 square plus 4 square. So these are squares of the even integers, right? And this will go up to n terms. So if we have even integers and we're going up to n terms, then the last term in this sequence will be simply 2n whole square, right? And similarly, for the odd numbers, the squares of the first n odd numbers, we can write their sum, and that's given as y. So y equal to 1 square plus 3 square plus 5 square, and so on. And this sum for the first n odd integers would go up to all the way till 2n minus 1 whole square. So having written these two out, we can now just do the subtraction. And here we will do a term by term subtraction. So if I can write x minus y is equal to, and then I'll do term by term. So I'll take the first term of x and then write its difference with the first term of y. So that will be 2 square minus 1 square, and that's how we'll group them. So this will make our problem much easier, as we're going to find out. And then the second term, the difference of those two second terms is going to be 4 square minus 3 square, and so on. The nth term will be simply 2n whole square minus 2n minus 1 whole square. Now we will take advantage of a middle school algebra formula, which basically states that a square minus b square is equal to a plus b multiplied by a minus b. And that will tremendously simplify things. So what is 2 square minus 1 square? If we write it in that form of a plus b multiplied by a minus b. So that becomes 2 plus 1 multiplied by 2 minus 1. Similarly, 4 square minus 3 square becomes 4 plus 3 multiplied by 4 minus 3. And then we can go up all the way till the nth term, which will become 2n plus 2n minus 1, and then multiplied by 2n minus 2n plus 1. And note that the a minus b term in each of these, so that's the term that's underlined, so that actually becomes 1, simply 1, right? So we can actually pretty much eliminate the term from the product, and we can write this as simply 2 plus 1 plus 4 plus 3 and all the way till 2n plus 2n minus 1 for the last term, for the nth term, right? And this can be further rewritten simply as 1 plus 2. So 2 plus 1 can be written as 1 plus 2. Similarly, 4 plus 3 can be written as 3 plus 4. That's pretty simple, right? And then the last term can be rewritten as 2n minus 1 plus 2n. And now we observe that this is simply the sum of the first 2n positive integers, right? So we are taking the sum of 1, 2, 3, 4 all the way till 2n. And here it's useful to recollect a formula that we have for the sum of first m positive integers, which is simply equal to m multiplied by m plus 1 divided by 2. So if we substitute m equal to 2n, because we are having the sum of first 2n positive integers, so we can write that sum as equal to 2n multiplied by, within parenthesis, 2n plus 1 divided by 2. And this is what's given as 1275. So we can write 2n multiplied by 2n plus 1 is equal to 1275 multiplied by 2, and this is equal to 2550. Now from here on, you have two potential ways to go about this. The first one is to solve a quadratic equation and find what the value of n, which works okay, but it's of course more time consuming and not really ideal for timed tests. The second method is what I would recommend if you are doing a timed test on this. So you try to basically break up 2550 as the product of two consecutive integers, because on the left hand side you have 2n multiplied by 2n plus 1, and so those are basically consecutive integers, right? So 2n and 2n plus 1 are two consecutive integers. So on the left hand side is the product of two consecutive integers, right? And the question is, can you express 2550 as the product of two consecutive integers? So if I divide 2550 by 5, it's easy to see it will be a multiple of 5, right? So if you divide by 5, it comes to 510 multiplied by 5, right? And so 2550 can be written as 510 multiplied by 5, and then if I take the 0 and put it at the end of 5, I can easily do that, right? Because it's a product, so I can actually shift the 0 to the second term. That will become 51 multiplied by 50, and which is the same as 50 multiplied by 51. So I have basically the product of two consecutive integers. So I've expressed 2550 as the product of two consecutive integers, and from this I can write 2n is equal to 50 and n is equal to 25. So the correct option in this case will be option B, 25.